We were at that point in learning about how to draw where we're finding out how to depict circles and circular objects is becoming important. Nothing can make a drawing look less convincing than having circles that don't look right in perspective. This is an important concept. Circles are literally everywhere. You can't look anywhere in an environment without finding them. Cups, trash cans, bottles, plates, clocks, steering wheels, and tires are but a few examples. For right now, I want to look at a more concrete example. So here's an ordinary dinner plate that I photographed on my dining room table. You get the idea, it's round. A circular object, when you're looking at it at 90 degrees to level, is a circle. Here I'm looking straight down on the plate. As I go through these, note that the blue lines on either side of the plate, these are the rule lines in Photoshop. Here I've dropped the camera down just a couple of inches so that the circle is becoming an ellipse. It's not very noticeable yet, but it will be as we go down. Here it is a bit lower, and still a bit lower. It's now looking more like an oval and less like a circle. Technically, this is what we call elliptical. Here I'm at about 50% of the way down. Again, notice that the rule lines on either side, those lines or those sides edges don't look flat, nor do they appear to be becoming anything other than round. Many people when drawing ellipses tend to flatten the edges, and the two keys to remember when drawing ellipses is to draw them narrower at the top and never allow the edges to become sharp or pointed. Also notice that the rule has become flattened, or the circles become flattened into the ellipse, and that the rules lines are consistent. That is, that they always are touching the outer side edges of the plate, no matter how flat that it becomes. The distance from one edge of the plate to the other hasn't changed, while the other one has. Even when we are almost flat, in line with the plate, the outside edges never become pointed or sharp. This is how you can tell if you've drawn a proper ellipse. The ellipse will eventually level off into a simple line, but the extreme edges will never become true points. Before there were computers and everything was in digital drawing, illustrators and designers had to draw everything by hand. We had tools to draw ellipses when we wanted to speed up our drawings or to make them extremely accurate. However, the problem with tools like ellipses, they were limited in size, and they didn't come in every degree imaginable. Ellipses occur from 90 degrees or a full circle all the way to 0 degrees or a flat line. Ellipse guides were in 5-degree increments in intervals from 55 to 15 degrees. But what happened when you wanted to draw an ellipse at 7 degrees? Well, you had to become proficient in sketching and sketching quickly. When we view a circle at an angle, we call that an ellipse. We refer to this viewing angle in terms of degrees. A perfect circle is at 90 degrees. At angles less than 90 degrees, we see various degrees ellipses that decrease until we are at 0 degrees. This is a straight line. Understanding the mechanics of drawing an ellipse is not difficult. Mastering the drawing of an ellipse is. An ellipse has two axes. The major axis, shown here, divides the ellipse across its long dimension into two equal halves. The minor axis, shown here, divides the ellipse into two equal halves across its narrow dimension. The major and minor axis cross one another at 90-degree angles. Here we have a square drawn around an ellipse. After drawing a square in perspective, draw an X across it from corner to corner. This locates the center. When looking at the major and minor axis of the ellipse, notice that the minor axis passes through the center of the square, while the major axis does not. Also notice that the ellipse touches the square exactly in the middle on each side of the square. These are called tangents. Here we have taken a symmetrical shape, an ellipse, and dropped it into perspective. Regardless of how your ellipse is depicted, rolling on the ground or resting on it, the construction should remain the same. Since the minor axis always goes through the center of the square, this is something that can be used to help in drawing it. Knowing that the tangents always touch the edge of the square exactly in the middle can be used to help determine the fullness of the ellipse. Practice drawing ellipses without worrying about locating them in perspective. These all represent a bunch that I've drawn in my rather rusty hand. Draw various sizes and different degree ellipses. After you draw an ellipse, identify its minor axis by drawing a line across its narrow dimension. The line divides each side equally, like this. Start with an ellipse. If I draw a line across it in a fashion trying to determine if this is the minor axis, I can prove that it isn't by folding the drawing over itself. It doesn't fold accurately, and so we know that it is drawn incorrectly. If the minor axis is drawn correctly, where we make the fold, it will create a mirror image when folded. This way, we've done it correctly. When drawing wheels on a car, the first thing to check is whether your minor axis is drawn correctly. The minor axis is always common to the axle of a car. Most of the time, this axle is also perpendicular to the center line of the car. There are some cases, such as where the front wheels are turned in or the wheels have been set with an extreme camber, that they no longer are perpendicular to the center line of your vehicle, but it isn't often that this is the case. Another way to illustrate the minor axis is to relate it to the propeller on an airplane. Here the minor axis of both the propeller and the fuselage are parallel to the center line of the plane. Therefore, they go to the same vanishing point. Remember when creating perspective drawings that all parallel lines go to the same vanishing point. Assuming the minor axis of your ellipse is correct and your ellipse still looks wrong, it can only be one thing, that you've got the degree set wrong. First, draw a box in perspective around the tangent points on your ellipse. Be sure to follow your perspective guidelines. Second, observe where your drawn ellipse contacts the box that you've drawn. If your ellipse does not touch the middle on each side of the box, the degree that that ellipse is drawn at is wrong. So, just as I described to you in the video that we had at the beginning of the class, the importance of memory of motion and things as it related to the Karate Kid, a lot of this stuff about drawing is that very same thing, that memory of motion kind of thing, and that's what ellipses represent. So what I'm going to do here first is I have drawn a horizon line and given you a vanishing point here. What we're going to do is we're going to construct very quickly a one-point perspective so that I can demonstrate to you how to go about laying out ellipses in a one-point perspective. So what's key about this is making sure that when you're laying out a one-point perspective and using it to construct an ellipse for this demonstration, I'm going to give myself a center line down the middle from the vanishing point, because what I want to do is I want to make sure that my lines demarking the one-point perspective end up equidistant on either side of that line. So these are the lines stretching back to the vanishing point. So we'll probably end up drawing something of a kind of a squat rectangular box standing on its end as opposed to a cube. The base of the box is going to be located right here. And as we know, in one-point perspective, the sides of a box are perpendicular to the horizon line, or straight up and down. So draw those lines up. Now we're going to establish the back end of the box in perspective, the part that rests on the floor, and that's going to be located right here. So this is the base of our rectangular box, and of course those lines stretch up again. All right, so this is the bottom box, and I'm going to locate the center here for establishing the ellipse. And then we're going to come up here and we're going to do the top of the box. I'm going to stay down a little bit this time, because what I end up with is a very shallow box at the top.
because it's going back to the vanishing point much faster than the bottom box. And then that represents the top square. So we have a rectangular box, rather squat, with a top and a bottom. And inside that we're going to have to construct some ellipses, because what we're really drawing here is a cylinder. Alright, so to roughly lay that out, if you remember correctly, an ellipse must touch the sides of the box at 4 points. Here, 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 and here. Same thing up here. Here, 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 and here. Now that being the case, you can see that the top ellipse is going to be much shallower than the bottom ellipse. And I'm just going to kind of roughly begin to draw this in here. So you can see how this memory of motion thing that I was talking about becomes important, because you have to kind of get used to doing these things over and over again. And that's what I would recommend when you're doing ellipses, is to continue to practice drawing them, because it's as you can see, it's a little bit tricky, and I'm kind of rusty at this. So you can see the top ellipse is much shallower. Now I'm going to use my ellipse guides here real quickly to show you where those ellipses might lie. I'm thinking the bottom one is probably 25. You can see 25 is too full. It's going to touch the sides of the box here, but it's going to be above and below the sides of the box there. So I'm thinking that it's probably more like a 20. And I have one over here. Here we go. I think it's probably going to be a 20. Yeah, 20 comes pretty close. Now, as you can see from what I was saying in the first part of this, that when it comes to drawing these things, if you don't have ellipses that fit these things, let's say for instance this was a 22-degree ellipse or a 23, you'd be kind of stuck. Whereas nowadays with computers, a lot of that stuff you can get away with, because computers will allow you to do stuff. Now this top one, I'm thinking is probably going to be a 10, but it might be a little less than that. And it's looking like it's probably more like a 5, if you can see. I'm going to go ahead and just dummy in a 10 for the sake of this demonstration. You can see it's a little bit more full. And that's the case. I don't have a 5. If I had a computer, it would be much easier to do. So I'm going to move my ellipse up a little bit here. I'm cheating. So what I want to do is kind of make it look like this is actually a 5 when it's really a 10. So there's my top ellipse and here's my bottom ellipse, and now all I have to do is connect the two sides up so that I have the cylinder. And of course, knowing that the bottom of the cylinder is drawn to 20 degrees and the top is like merely 5, that only means that there's maybe a 15 in between. So you might actually have a full 10 in here someplace, and then halfway down you may end up with a 15-degree ellipse. Anyway, a 15 would come somewhere in the middle here. And here's where the 10 would go, somewhere halfway between the, or quarter of the way between the 5. So as you notice, the edges of the ellipse are always round. That's the thing that is key here, is to making sure that your ellipse never comes to a point when you're drawing it. It should always be a nice rounded curve where you're drawing it. I hope this helps. All for now. I'll see you guys in the next video.